dot product of we have to discuss the dot and cross product of two vectors. First we will discuss dot product. Dot product is also called a scalar product of two vectors. A scalar product of vector is defined as vector A dot vector B, which is equal to A B cos theta, where A here is mod of vector A, B here is mod of vector B, and theta is angle between vector A and vector B. It is also called a scalar product because the result is actually scalar. A dot B may be positive, may be negative, may be 0. Here, if the dot product of the two vectors is positive, if A dot B is positive means the angle between them is acute. If the dot product is 0 means the two vectors are perpendicular. If the dot product of two vectors is negative, then the angle between them is obtuse. These are the three conclusions which we can draw while taking the dot product of vector A and vector B. As we know I cap dot I cap. So this is vector I cap. This is also vector I cap. So angle between I cap and I cap is 0. So I can say I cap dot I cap is mod of I cap. In place of A, here it is I cap. Mod of I cap is 1. Mod of I cap is also 1, and the angle between these two is 0. So I dot I is into cos, I dot I is 1 into cos 0, which is equal to 1. In the same way, J dot J is also 1. K dot K cap is also 1. But I dot J, this is I cap and this is J cap. As we know, the angle between I cap and J cap is 90 degree. So mod of I cap is 1, mod of J cap is 1, but cos 90 is 0. So I cap dot J cap is 0. So J dot K is also 0 and K cap dot I cap is also 0. Now we have to take the dot product of A, that is equal to 2I cap plus 3J cap. Find the dot product of A, that is 2I cap plus 3J cap, and B, that is equal to 4I cap plus 2J cap. So A dot B can be written as 2I cap plus 3J cap. In place of A, I can write it as A as 2I cap plus 3J cap from here, and in place of B, I can write here 4I cap plus 2J cap. Now I will multiply this A dot B as 2I cap multiplied by taking the dot product of 4I cap plus 2J cap plus 3J, it is 3J dot of 4I plus 2J, which is equal to A dot B, it is 4 into 2, that is 8. For a scalar, dot product is simply multiplication. So 4 into 2 is 8. I dot I is 1. 2 into 2, that is 4. I dot J. 3 into 4, 12. J dot I. 3 into 2, that is 6. J dot J. So it is 1. I dot I is 1. I dot J is 0. J dot J is 0. So these two terms will vanish. We get 8 plus 6, that is equal to 40. So A dot B here is only 40. Whereas we can also do dot product like this. I have to take the dot product A dot B. So I will put here A, 2I cap plus 3J cap, and B here of A and B are multiplied together. So it is 4 into 2, that is equal to 8. This is 3 into 2, that is 6, and both are added, so we will get 40. Dot product is used to calculate the component of vector along another vector. Suppose this is vector A, this is vector B, this is vector B, this is theta. So I can say this length is A cos theta. This is A cos theta. A cos theta can also be calculated from A dot B. We know A dot B is AB cos theta, or A cos theta is vector A dot vector B by mod of vector B. So this is called component of vector A. This is A cos theta is called length of component of A along vector B. This is A sin theta. This is A sin theta. So this dot product is also used to calculate the projection of one vector along another vector. Similarly, we can say B cos theta, which is projection of vector B b cos theta can be calculated as vector A dot vector B divided by mod of A. A sin theta can also be calculated by root over A square minus A cos theta square. So this is A sin theta mod of A sin theta. We know this magnitude is A. This is a right angle triangle. So we can say A cos theta square plus A sin theta square is equal to A square. So from here you can say A square is equal to A cos theta square plus A sin theta square. So A sin theta can be written as A root over A square minus A cos theta square. This is the component of vector A perpendicular to vector B. Now for example, find the length of component of vector A along vector B. This is vector A, this is vector B. So we'll draw vector A, this is vector B. Let this angle be theta. I will take component of vector B, so I will draw a line like this. This length is A cos theta. So A cos theta can be written as A dot B. As we know, A dot B is 2 into 1, that is 2, plus 4 into 3, that is equal to 12. It is equal to 14. So A dot B, vector A dot vector B is equal to 14. So I will write here 14. And the magnitude of vector B is root over 3 square plus 1, that is root 10. So A cos theta is A dot B divided by mod B, that is equal to, as we know, A dot B is 14 and mod of B is root 10, so it is 14 by root 10. This is 14 by root 10. This is length, this is projection of vector A along vector B.